Now we are reading the Bluetooth. Seen this on the screen share. Have you checked? Can you check it? Device found. You can see the device found.
Yes.
BLE sensor interface.
I'm just going to blow this out to full screen. Okay, this is much better. All right, I can see it now.
Okay. Now we are connecting it to our sensor. Now we have given option for enabling and disabling the update rate update for particular sensors. In the sense, if you write 01 to the particular sensor, it will enable the notification.
Okay.
Else it will disable.
Okay, so 01 is the code to get it to transmit.
Yeah. Now you can see I am entering 0100.
Okay, I saw you doing this yesterday. I was wondering what you were doing. Okay, so
Yeah.
you're telling that particular port
Sensors.
on to turn on.
Yeah.
Got you. Okay, so I'm seeing different values coming up to the left.
Right. The left is actually we are writing to the device.
I see. Okay.
When as soon as we apply the change here, it will be written to our Bluetooth device.
All right. So you're doing 0.0. What is that telling the device?
That is actually we are disabling the sensors of the analog sensors.
Okay, got you. Got you. The analog sensors.
We have 3 analog inputs, right?
Yes, sir.
That one we are disabling right now.
Right. On the
rest of the remaining all the almost 3 plus 3, almost 6 sensors we have enabled right now.
All right, so there's a temperature sensor, a humidity sensor, and a pH sensor, and then we have the temperature and humidity on the main board, right?
Yeah. The first one, the below just one right now, which I have selected, it's for battery level.
Oh, cool.
Okay. The followed next one is pH sensor.
Okay, number 15.
Yeah, number 15 is pH sensor.
Okay.
Number 19 is humidity, I think.
Okay.
Number 23, temperature.
Yes.
These 3 are the sensors on the sensor PCB.
Yes.
Next, then followed by 27.
Which is the temperature sensor on the main board?
Yeah, that is room temperature and room humidity.
Excellent.
Okay, now in order to, let's say if you want out of the 6 sensor, in case if we want, we have grouped it in the form of 8 bits.
8 bits, got you.
In the sense, in case if you want to read only pH sensor, we need to enter a value 01.
Right, to tell it to sample, right?
Yeah, we are sending a request to the Bluetooth device mentioning that we need only value for pH. In case if we want all the 3 or all the sensors, we have to input FF. In the sense, we are enabling all the sensors.
Okay.
Let's say I am giving value FF.
Which is what you want. You're doing it manually, but when you write the app, it'll do it automatically, right?
Yeah. When we have option for entering manually right now,
right.
We will change it in the app. We will be setting a timer levels, and we will be sending this value regularly, gotcha. And we will be getting the value.
So FF is the code to go ahead and read the value, correct?
Yeah. In the sense, it is for all sensors.
Okay.
In order to get the values, I will send you a letter. I will send you one text document how we have framed that FF. I will explain you in a document.
Okay, that sounds good.
Now we have made the read request.
Oh, I see. Okay, so is the sensor now in a fluid?
Yeah, it's in a, you can see it's in water.
Okay, I'm trying. Okay, I'm look. Okay, that screen's a little small. I see it. Okay, you got in water, right?
water, and now it is in, we are getting the pH value as 47.
Okay, so what does that translate to?
47 means the it's actually it's in hexadecimal format. Hexadecimal 47. When we convert, it is 71. It is in decimal 71. Okay.
Okay, I see what you're saying.
Now the value what we are seeing is in hexadecimal, that is 47.
Got you.
When we convert it to decimal, the value is 71.
Is 71. Okay. So which is 7.1.
One, yeah, exactly.
Okay.
We have to divide it by 10.
Got you. Okay.
So we have 7.1.
All right. So now if you put into the 4.
Yeah.
Excellent. I'm glad you're cleaning it before every use. This is good because it'll keep it.
Yeah, because our buffer values will change, right?
Yes, they will change. Yeah. Okay. So you do another FF command.
Yeah. Now again we are sending some request.
Okay, 42. I just see it change. Okay, cool.
Now we are seeing 42.
Yep. Neat. Really neat. So it's probably like.
Right now it is showing around the 6.6.
Okay, 6.6, but that's a buffer of what? 4.
Yeah, it's actually buffer 7, but sometimes I have mixed some salts directly, or some changes it is reflecting.
All right, so here's a question. We have to have in this, and it's in the spec, the ability to do a calibration offset, correct?
Okay.
You understand?
Yeah, I understood.
Because
yeah, we can provide a future, not a problem.
Okay, good. I just wanted to make sure we have that ability. So in other words, I can make this 7. I can force it to be 7 if it's in the 7 buffer solution.
Yes.
Okay.
We will provide. We can add that future. It's not a problem.
Okay, good. All right, that's cool. All right, so back into water. And it's important, to keep these sensors in fluid when you're not using them, correct? You understand?
Yeah.
Okay. So the red is, I don't know, 4 or 10, I can't remember.
Now it is hexadecimal 23.
23.
Yeah, in the sense decimal, it is saying around 3.5.
Okay, so that's a 4% solution that you put it in.
Yeah. We have to actually adjust that one. We can just by entering some calibration values, we can do it. It's not a problem.
Got you. Okay, good. Three. Oh, I think you typed FD. Yeah, there you
go. Now it is hexadecimal 5E.
What is that, 5E?
Yeah. In the sense, it is saying 99.4.
So why
the error what we are seeing is linear.
Okay, but why is there an E on it as opposed to a number?
And hexadecimal means it starts from 0 to F.
Oh, okay. So the E is it goes in graduations of 10.
Yeah.
Okay.
After until 9, it will be new numbers. Then it will be A, B, C, D, E, F.
Got you. 15. Okay, you just taught me something. This is good. Okay, hexadecimal. All right.
Now this is, as you can see, the error we are getting is 5 points, 0.5 error.
Excellent.
So it's not no, it's just a calibration problem. We can correct it in ppm. It's not a problem.
Okay. All right. Yeah, because part of the spec is that this device temperature and pH and RH have got to be calibratable. You know.
Okay.
I've got to be.
Temperature, I think no need to calibrate because the sensor itself comes with a calibrated, factory calibrated. Temperature won't change.
What the sensor for the temperature and humidity does?
Yeah.
Thank you for showing me that.
You're welcome, sir.
You can call me Mark.
Surely.
Um,
Now, right now, if you notice that now we go for temperature and humidity.
okay, sounds good.
As you can see, right now the values is 36 and 0104. The 36 is humidity actually.
Is that like direct conversion, 36% relative humidity?
No. It is in hex format right now.
Okay, right. Okay.
Hexadecimal. When we convert it to normal decimal, it is 54. In the sense, 54%.
Okay, 54% at where you're sitting. Okay, cool. Excellent.
Yeah. Then the temperature following is around 0104 hexadecimal.
No, 0401.
And we have to take it in reverse order.
Oh, okay. I'm sorry.
So we will be getting decimal to 260. In the sense, 26 degrees, 26.0
Celsius.
Okay, now we will try to make some temperature shift there, and then we will read. I'm blowing right now.
All right. You hit FD.
As you can see, the temperature has been changed a little bit. I have blown on the sensor.
So what does FD mean? You did FF on the other ones.
You can see the temperature and humidity shift right now.
Oh, yes.
I will send you the how we are calculating the request code. You can call that FF or FD as request code. Okay.
Request code. Got you. Okay.
Request code. In the sense, what are the sensors we have enabled or what are the sensors we are requesting. Depending upon that, we are going to calculate a value. I will explain you how we are calculating it in a separate document.
Okay. So how do you know? Which one is what? Just because you've got it written down? I mean, can you change the name on this screen to reflect temperature, humidity, or you don't need to?
Actually, we are while programming, we are programming it in a predefined pattern. In the sense, everything will be followed on the same way.
Okay. All right.
Based on that, we are following it and we are calculating the values.
That's amazing. Okay, that's good. I'm glad you know what you're doing.
If we go for naming structures and all, we will get a problem of over transmission. In the sense, data transfers will take so much time, and also power consumption also will be more.
Okay.
So we are better to keep all the transfers minimum. The rest of the thing we can calculate in app.
Okay. Have you been able to get an idea of what the power budget's going to be?
Power budget, right now with this device I calculated it is taking around 5 milliamps.
5 milliamps?
Since we have got all the peripherals on all the time, it is taking around 5 milliamps right now.
And that's inclusive of the Bluetooth board and everything?
Yeah. I am measuring at the input source. So it includes everything.
Okay, is that good or is that seem like a lot of power to you?
I thought this is it's taking so much of power right now. That's why in the second version, yesterday night I have redesigned one more design right now.
Okay.
In
All right.
that design, what going to do is I'm going to switch on the power for the peripherals. I mean the sensors during scan request only. Rest of the time it will be in off condition.
Gotcha. Which will save energy. Okay.
Yeah, while only Bluetooth is enabled, under sleep it is taking around 1.5 to 2 milliamps.
Okay, which is much better. Okay.
Yeah,
5.22. Yeah.
always it will stay with the 1.5 or 2 milliamps. Whenever we make a request for scanning the sensors, at that time the power controller will on, and we will be at that time the consumption will be around 5 milliamps, and it will get back to normal 1 milliamp or 2 milliamps.
Got you. While
So
it's
it
while
is
sleeping.
so much of power.
Okay. No, that's good.
That that's one I'm yesterday night I redesigned that one. Need to make the one more PCB for that one.
All
Need
right.
to make all changes.
All right. All right. Let me. I'm going to transfer some money today, and I'll get it over to you so we can get you paid. I really appreciate everything you've done. I'm still trying to connect with the company. Let me shut my screen recorder off.